I'm pleased to introduce Jennifer Ryan, who worked with Professor Overby in the theater department on a project called Math That Moves You. And I have a personal interest in learning about this because I like to dance. So I do. I'm a ballroom dancer, so maybe I'll learn something about mathematics learning this way.
Thank you. As you said, my name is Jennifer Ryan, and the title of my project is Math That Moves You. I'd like to start by showing this image that I found written on a classroom desk. It appears that one student etched in the desk the words, "I'm bored," and then other students added, "Yup, me too," and then me, 3, 4, 5, and 6. I found this written on a desk in a classroom, and I found it very interesting. And I'm curious to know what age group you think used this desk. So please raise your hand when I call out the age group. So kindergarten through 2nd grade, 3rd grade through 5th grade, 6th through 8th grade, high school, college.
Could be all of the above.
I actually found this right here on our campus in and it is evidence such as this that shows that students are not engaged during learning. This type of evidence is what made me want to search for ways to keep students engaged in learning beginning at a young age, so that by the time they reach college, they are intrinsically motivated to stay engaged in school. As a dancer and education major myself, I thought that integrating dance into core curriculum subjects might help students remain engaged and interested in the material. After completing a literature review, I found much emphasis on Kolb's experiential learning theory. When students engage in experiential learning, they are directly involved in a concrete experience, and after reflecting on the experience, they can apply what they have learned to new situations. Kolb's research also showed that learning through experiences led students to become self-directed learners. Therefore, the purpose of my project was to study the effects of a dance and math integrated curriculum on the attitudes and knowledge of 2nd grade students. According to the Kennedy Center, a comprehensive definition of arts integration is that it is an approach to teaching in which students construct and demonstrate understanding through an art form. Students engage in a creative process that connects an art form and a subject area and meets evolving objectives in both. So that means that during the lessons, the students are actually learning the content through the art form, and there are specific goals and objectives in both the content area and the art form. So in order to do this, I created a 2nd grade mathematics curriculum that integrated dance and math using the Common Core state standards, which are the national standards for math at each learning grade level, as well as the national standards for dance. The curriculum contained 2 lessons to introduce the basic elements of dance, since none of the students had dance training in school already. And it included levels, pathways, directions, space, and locomotor versus non-locomotor movements. The curriculum also contained 5 unit lessons that integrated these dance elements into the math topics of the 4 basic operations, which are addition, subtraction, multiplication, and division, a lesson on geometry, and a lesson on measurement. One example of an integrated activity is from my lesson on multiplication. The students were given the name of a movement, such as gallop, and made a symbol on a card to represent that movement. After getting into groups, they were given a multiplication problem and had to make an array on the floor to represent that problem. So for a problem such as 4 times 3, they made 4 groups of 3 dance moves, as you can see in the picture. After laying their cards out on the ground, they had time to practice and perform their choreography in front of the class, and they would end their dance by telling how many total movements they had in their piece. I pilot taught this curriculum to a 2nd grade class of 19 participants at a charter school in Wilmington, Delaware, and this past winter session I taught it again to another group of 22 participants at Downs Elementary School in Newark, Delaware. I also collected pre- and post-test data from a control group. This control group was taught mathematics based on the Common Core standards through a traditional lecture-based approach with whole group instruction followed by group or individual practice by their classroom teacher. This summer, my focus was on analyzing the quantitative and qualitative data that I collected. Quantitative data was collected in the form of a summative pre- and post-test on information regarding the dance terminology and mathematics content taught. The quantitative data showed an increase in the mean for the experimental group from pre-test to post-test in both the math and dance content areas. On the math portion of the test, the average score was a 5.4 out of 13 on the pretest and 6.9 out of 13 on the post-test, which showed a 28% increase. On the dance portion of the test, the average score on the pretest was a 3.2 out of 12 and 7.95 out of 12 on the post-test, which showed a 146% increase. Paired t-tests were also performed to test the significance of this data among the experimental group, and p-values of less than 0.05 showed that the change in mean from pre to post-test in both content areas was statistically significant. Paired t-tests were also performed to test the significance of the data comparing the math content pre-test mean scores and post-test mean scores of the experimental and control groups. The p-values calculated when comparing both the pre and post-test scores were greater than 0.05, showing that these mean scores did not have a statistically significant comparison. This shows that before the curriculum was taught to the experimental group, there was not a significant difference in scores between the experimental and control groups. Similarly, after the curriculum was taught to the experimental group, there was still not a significant difference in their scores on the mathematics content. It is important to note that both the experimental and control groups were still receiving math instruction from their regular classroom teachers, but only the experimental group received the additional dance integrated math instruction. Qualitative data was also collected through video footage of each lesson, student journal reflections, teacher reflections after each lesson, and a cooperating teacher questionnaire after the study. The qualitative data analyzed from these assessments displayed an increase in engagement, creativity, and growth in the art form among students who experienced the integrated lessons. For today, I have selected 3 examples of the qualitative data. The first was a journal question that was, what did you like or not like about today's activity and why? Each of the 3 selected responses were positive responses from the students, and they all showed that the students enjoyed learning in this active manner, and they all realized that learning can have an element of fun. The students noticed on their own that learning and fun were occurring simultaneously in the lesson. The next piece of qualitative data is video footage from both the first performance and the last performance. The first time the students performed in front of their peers during a lesson, they were to create a dance on their own, making an asymmetrical shape at a high, middle, and low level. So from this video, we can see that the students who were performing were looking at each other. Some of them hesitated. They did not follow all of the directions, either by not including all of their levels or using asymmetrical shapes. There was noise coming from the student audience, and the students had incomplete dances. The last time that the students performed in front of their peers, which was only 2.5 weeks later, the students were to take a specific number of dance moves and divide them up between the dancers in their groups so that each dancer performed the same number of moves. Comparatively, we can see that both the performers and the student audience were quiet. They did not need prompting from the teacher. They followed the directions, had complete dances, and used creative movements. After a lesson on asymmetrical and symmetrical shapes, the students were asked to draw symmetrical shapes and then asymmetrical shapes in their journals. 44% of the students who answered the 2 questions drew pictures of either people or stick figures in symmetrical or asymmetrical shapes. I found this significant because these are much more complex shapes than simply drawing a circle or a triangle, and it also showed the students' creativity in embodying these symmetrical and asymmetrical shapes with their own bodies. Based on these results thus far, I have found that integrating creative dance into math lessons appears to be an approach that maintains students' achievement in the core curriculum content and shows an increase in student engagement while also fostering creativity and promoting their artistic growth in dance. In the future, I plan to use these arts integration methods in my own career as a teacher, as well as promote the use of arts integration techniques among other teachers. At this time, I'd like to bring you back to the first image that I showed. With a show of hands, if you were able to engage in learning in an arts integrated classroom, how many of you would have been doodling such statements onto your desk? I would like to thank my advisor, Dr. Overby, my graduate advisors, and cooperating teacher, and I would like to also thank all of you for attending this presentation today, and I'm happy to answer any questions that you have.
We have some time for questions.
Okay, so I have a tough question.
Okay.
Because you actually did something that's distinctive so far, and that is you had an experimental and a control group. And none of the other presenters so far had a comparison condition. So you showed through your analyses that with respect to mathematical understanding, it appeared that both the control group and the experimental group improved over time, and there wasn't a difference between the two groups. So I know that you're enthusiastic about dance, and I am too. Okay, I love to dance, and I believe it has the potential to improve people's understanding of mathematics. I believe music does the same, and all of the arts. But are you a little bit concerned from the outcome that perhaps you didn't really show a different understanding or better understanding for the experimental group?
I am a little bit concerned, but the thing was, I was only in the classroom for 5 weeks because I was only there during winter session. So I would be curious to see if it expanded over a longer period of time, if the students' actual understanding of the math might have changed more. And I think I did see some things in, like with the symmetrical and asymmetrical shapes, how they were using more complex shapes and using their bodies to do it. And in addition, other than through this, the students don't get any dance instruction in school. So even though it's not really taking away from their learning in math, they're still getting their learning in math, and in addition, getting this dance instruction that the control group, or the control group didn't have. Yes.
Would you be willing to venture a guess about the potential that learning through an interdisciplinary means would have on retaining the information that they learned?
I don't have any data to back it up, but from some of the research that I've done, it does seem, from my literature reviews, it does seem that people do remember, because like with the experiential learning, if you're actually doing it and being a part of it and using your body, you retain things better that way. Yes.
Yeah, that's kind of what I got from your study, was that what your intervention did is it didn't hurt the mathematics instruction. But what I was thinking, do you have any ideas of what you would do if you had more time to develop a mathematics understanding? Like when I looked at the multiplication tables, I thought that activity would work really good with spatial area, like helping students understand what the size of 12 was in 3 by 4.
Absolutely.
Maybe not so much with just a number fact. Do you have any other ideas?
I think with more time, I also would have brought it into fractions and done some work with fractions, or even time, like dancing fast and slow and speed. There's a lot of applications you can do with science and history. I mean, there's so many things that you can do with it. But I just, because I had a short amount of time, I just kind of had to focus on the basics.
Dance is done with music, usually.
Yes.
And so music gives you an opportunity to learn about intervals and how intervals get divided and repeated, and so you learn sequence
Yes.
and things like that. So those are other opportunities or other things you could focus on in the future.
Definitely, thank you. Yes.
What would you do if you were working with older kids? So you did this with a particular age, but what if you had math topics that were for older?
I think with older groups, there are also ways to adapt it, especially getting deeper into different types of geometry. There are ways to adapt them that way. And especially with graphing, you can do a lot of things with like graphs, like making human graphs and like doing other things with your bodies. So there are definitely ways to adapt it for older students as well.